Welcome to this introduction on the Progress LoadMaster Ingress Controller for Kubernetes. The Ingress capabilities on LoadMaster can be delivered in two different modes, Ingress Mode and Service Mode. Each one providing different capabilities to ensure organizations can adopt and gain the benefits of Kubernetes in their environments. This demonstration will focus on Ingress Mode. Ingress Mode is the more traditional approach for publishing Kubernetes applications where the Ingress object in Kubernetes is leveraged. The Ingress object defines a configuration on the LoadMaster to publish the services within the cluster. To enable the Ingress capabilities on LoadMaster, navigate to Virtual Services and Kubernetes Settings and click Install. The Ingress Controller package will automatically get downloaded and installed on the LoadMaster. Once installed, we just need to refresh and continue with the configuration. The configuration to get connected to Kubernetes is to simply select the operational mode, and in this example Ingress, and upload the kubeconfig file that was already extracted from Kubernetes that is running in the environment. Now that we have the connection established, we can move into Kubernetes to deploy a few apps to publish through the LoadMaster. I have a few YAML files, starting with the guestbook.yaml. Here I have 3 deployments, Redis leader with 1 replica, a Redis follower with 2 replicas, and the guestbook front end with 4 replicas. In addition, I have the 3 services, 1 for each deployment. Now looking at the voteapp.yaml, this consists of a backend deployment, Azure Vote Back with a single replica, and the front end Azure Vote Front with 2 replicas, as well as the services for each. Now I'll just go ahead and use the kubectl to apply these. Now, if I do a kubectl get pods, I can see all the replicas I've deployed. Here, I want to capture the details of the networks the pods are using in my environment, so I can add these as additional routes on the LoadMaster. This will be required so the LoadMaster can successfully route traffic to these pod endpoints. I'm doing this step manually, but there are different approaches that can be used to automate this configuration. So here we see the pods that are running in the 10.10.142 subnet are running on kubeworker 1, and the pods that are running on 10.10.77 subnet are running on kubeworker 2. Going back on the LoadMaster and navigate to System Configuration, Network Setup, and Additional Routes, we can add these networks, each pointing to the IP address of the worker nodes, worker node 1 and worker node 2. Now we can go look at the lmingress.yaml. Here's where we can define the LoadMaster virtual service configuration. Now this is just a small subset of the available annotations that could be used for LoadMaster virtual service settings in this Ingress object. Here we have the virtual service IP address, the port, protocol, and type. We have TLS SSL acceleration enabled with the name of the certificate to use. The Ingress class name lmingress to specify we're leveraging LoadMaster. And then the services we want to publish, the Azure Vote Front and the Guest Front. Here we're using unique URLs to steer the traffic between these apps, but unique paths may also be used based on the application requirements. So just apply this using the kubectl. And then jumping back to LoadMaster, we see the virtual service and 2 sub-virtual services created. And in just a few seconds, we'll see the remainder of the configuration come in, including the pods we deployed earlier for each app. A few content switching rules were also dynamically created as part of the applying of the Ingress object to Kubernetes. These will direct traffic based on the different URLs. I'll open up a new tab to make sure we can successfully connect to our new guestbook application, and all looks good here. Now the voting app, and once again, we're directed to the correct Azure voting front end where we can vote for cats or dogs. Now one of the many benefits for running in a Kubernetes environment is the ability to scale out when additional resources are required, or scaling back when they're no longer. So running the kubectl scale to put replicas to our guest front-end deployment to 6, and the Azure Vote front-end deployment to 5 replicas. We see the LoadMaster dynamically updates the sub-virtual services to add the additional pods as real servers. And now, scaling back down to 3, we see the LoadMaster has made the necessary adjustments. Hopefully, this short demonstration highlights the simplicity of using LoadMaster Ingress capabilities for Kubernetes using Ingress Mode.